Hello everyone, my name is Lucas Peterson and welcome back to another IBM Analytics demonstration. In today's demonstration we'll be taking a look at a familiar use case, which is customer churn within a retail banking environment. Again, we're going to be using the IBM Analytics platform, but we're also going to be using some open source components and programming languages. The goal will be to improve sales and customer satisfaction for our fictional bank. So you may be asking why we're doing this demonstration again. Well, this time we're going to be taking a different approach. So we look at this visualization. Our last attempt at providing this churn analytics was using the visual way of doing analytics. We use products such as Cognos Analytics, Watson Analytics, and SPSS Modeler that were more targeted towards a line of business that maybe didn't have as many programmatic or deeper technical skills with analytics. They're able to get up to speed quickly and provide analytics value using more user interfaces and drag and drop methodologies. So in today's demonstration we will be moving towards the programmatic approach. Again, we'll be using Cognos Analytics to identify some of our problems in the bank, but then we'll be using more of an open source and programmatic approach to building a machine learning model that can predict churn. So one key component in today's demonstration will be the data science experience. We'll get into more of that as we go into the demonstration. But oftentimes the question arises that what if your team has both kinds of people, visual and programmatic? And that's a question that we'll hope to solve by the end of this demo. To begin this demonstration, I'll take on the role of the business analyst. And it's my job to take a look at some of the sales and product data and provide insights for my executives. So I'm starting here in my mortgage sales dashboard today, where it's giving me a quarterly review of how our mortgage sales are doing. Across the top, I quickly can see some of my key performance indicators and understand how I'm doing in terms of my metrics. So I see things such as my mortgage sales are a healthy 11,000. My satisfaction score is somewhat in the middle of a 1 to 5 score at about 3. And my lost customers seems very concerning at over 4,000. It looks to be over 1/3 of all of our mortgage sales this quarter are resulting in lost customers due to something in the mortgage sale cycle. Below that I have some supporting visualizations so I can see where those mortgage sales are happening. It looks like the home state of Texas has the most mortgage sales in this quarter. I see the exact number there is about over 3,000. And then on the right I have my sales by seller, and something that I do periodically is just to check how each seller is doing, how they're progressing, and my executives like to know who are the best sellers so that we can compensate them more fairly. But right now this graph is a little bit somewhat jumbled and hard to read, so I want to get a more actionable list, understand who's really doing the best. Okay, so now I'm sorting them descending. I can see that maybe salesperson ID 17 is doing the best, but it's still somewhat hard to read and I want a more actionable list. So I'll just find the top 5 sellers for now. And there we go. Now I've got a very actionable list of who's selling the best overall. But again, back to our lost customers, that was something that immediately caught my attention and might be a problem within the bank. So I'd like to see this maybe a few different ways, see if this is a widespread issue or if it's local to maybe just one region or one seller. So to do this, I'm going to go into edit mode and do some more investigation. Bringing up my data on the left-hand side here, I want to create a new calculation. Instead of just our lost customers, I really like to see that as a ratio. I'm going to call it churn ratio and provide this expression. And all this expression is doing is if they are a churned customer, then we're going to count them. Otherwise we're not, and we're going to divide by the total number of customers, giving us a ratio. I can see my new metric below. I'm going to look at some of its properties. And I'm going to bring it into the dashboard so I can see that metric. Okay, so I was right. It's a little bit more than 1/3 at 0.38, or 38% of all of my sales are resulting in a lost customer. Now that's very much a problem for my bank, and I need to get on top of this issue. So I'm going to see if it's local to one state or one area by replacing our mortgage sales with the new churn ratio. Okay, and I can see that whereas Texas was selling the most mortgages before, it's not the biggest culprit in terms of churn. That role goes to states such as California, Colorado, Utah, North Dakota, and some others. Now I want to see maybe if my best sellers are having this issue as well. And wow, they are. I can see that even my best sellers are suffering from almost, seems like 40% of their customers are also churning, denoted by the different colored bars here. So this is not a local issue. This is a widespread issue between different states and different sellers. So I've identified a problem fairly quickly using this dashboard tool, but I'm going to now want to turn this information over to my data science team to see if they can understand why this is happening and maybe produce a machine learning model to help us get ahead of this churn problem. Now that we've identified a problem with churn, it's time to turn those insights over to the data science team so that they can begin to build a machine learning predictive model for churn so we can identify which mortgage customers are likely to leave the bank in the future and get ahead of the problem. As a member of that data science team, I'm now going to open my project for this use case and take a look at some of my assets. Now as a data scientist, I have a different set of skills than my data analysts do. I've been trained to use different open source languages such as Python and R, and different environments such as Jupyter Notebooks, RStudio, and so on. So I'm going to use some of my open source tools in my tool belt and come up with a predictive model for this use case. I'm going to start by opening my notebook that I've created. Now I've already created this notebook, so I'm just going to be stepping through it fairly quickly as it is rather code heavy and relies on some open source knowledge. So we'll start by taking a look here at the table of contents as to what this notebook actually does. It follows a very common data science practice. First, we're getting data, performing some operations. Then we want to understand that data before building a machine learning model and evaluating it. So the first step in building my machine learning model is to get data. We have our original data that our business analyst was taking a look at that has information about our mortgage sales. But to build our machine learning model, we also want to look at maybe some more data about our customers, such as their credit information. So to find data, I'll go up here to this tab, and I can see the different local files such as CSVs that I've uploaded, but I also have data stored in a remote DB2 database. And I can go ahead and pull that in by inserting it as a Spark data frame, which I've done here in this cell. We can take a look at all of the data that's been brought in. Our next step is to merge those into one single data frame so that we can start to do analysis on it. We're then going to clean some of our data by removing and renaming different columns. So we're going to remove the columns that we know that we do not need, and we're going to rename some of the columns so we can fit them into our machine learning model. And this is a very iterative process. I've gone through multiple times creating this model using different columns and features of the data source, so I know which ones to take out, which ones do not matter, and which ones are very crucial to the model. And this is a very common process for data scientists. So once we perform some operations, now we have a nice clean data set of more feature-rich columns that we know are going to affect our customer churn. After we have our data, it's time to understand the data. And we're going to use some visualizations. To build these visualizations, we're using the open source language of Brunel that IBM has committed to open source. And we're just taking a look at some simple plots here so we can better understand our data. In the bar chart, we're showing that most of our customers are personal, meaning they do not belong to a corporate or a small business account. And that churn is uniform across all three segments. Over on the right, our pie chart shows that most of our mortgages are in the 300,000+ category. Now down below, we're just taking a look at how a couple of different features, our credit score of our customers and our average monthly fee, are related to each other. And we can see that they're fairly closely related, so it might be a good idea to include maybe one instead of both, as it might skew the machine learning model in the future. And then we've drawn a trend line across the intersection there. So next it's time to build our machine learning model, and to do so we're going to be using the Spark machine learning library. We're going to bring in our logistic regression model from that machine learning library, as logistic regression is a great way to classify customers into a couple of buckets. In this case, we're going to classify them into likely to churn or not likely to churn. So just binomial, 1 or 0. And we're going to run our model here against our training data and our test data. And the next thing we want to do is really score the test data and understand how accurate our model is. Again, this is a very iterative process. As a data scientist, I might do this for a few days until I get the model into a reasonable accuracy. In this table, I can see the actual data and how each customer performed, as whether they churned or not, and then whether we predicted that they churn or not. So it looks like we're matching up, at least for these first 5, we're matching up fairly closely with our actual results. Next, we'll want to evaluate that model. I can see that the model precision is about 84%, which is fairly accurate for this dummy test data. And then we want to save our model so we can use it into testing and production use. Now that we've created our model, it's time to put it into action. And we need to score our existing customers and find out if they are likely to churn as well. So back inside our data science project, we can take a look at our assets page again. Again, we see that notebook we just ran through. And down below, we have a nice governed view of our model. It's no longer floating around in some data scientist's laptop, and if they lose that laptop or if they leave the company, we lose that model altogether. We can clearly see the version and the model here in a governed page. We can find information about our model from this page, such as the type is Spark, the algorithm, and the engine. We can also test this model directly from our page, so we have a list of inputs here. And we can see that given these inputs, this person is not likely to churn. But now we need to actually score our existing customers. So to do so, we're going to go ahead and run a batch scoring job from inside of this environment. We can find our current customers and write this to a predicted customer set and generate the batch script. And we can edit this batch script from directly inside here and then run it to score all of our existing customers. Now that we have our predicted customer set, it's time to act on that. We should create some type of report to let our sellers and executives know which customers are likely to churn in the future, so that we can get ahead and go ahead and get them on the phone and find out what's going on and if we can stop them from leaving the bank. Now within RStudio, we've created what's known as the Shiny application. So from our studio, we've created a Shiny application, and this is a way to create a report using an open source language and library and host this from within your data science experience. So we can go ahead and narrow this report down. I live in Washington, so we will look for Washington. We will look for Seattle. Let's find sales ID 15, and we'll look for only those that are likely to churn. Then we can sort this by predicted churn confidence and find that we have now about 3 pages or 26 entries for this sales ID, this salesperson that needs to get these customers on the phone and I understand what's happening so they can prevent them from leaving the bank. So thank you for watching this short demonstration. I know the demonstration was fairly short and we didn't have time to cover all of the unique features of the data science experience. But at the beginning of this demo, we posed this question. What if your team has both kinds of people? Both business analysts that prefer to work in a visual drag and drop methodology that maybe are not as highly trained, and programmatic, highly trained, open source data scientists. Well, the data science experience really seeks to solve this type of problem and allow both people to work together in one single environment, one single platform, to really provide a lot of value to analytics. So the data science experience local is really a true data science platform. It has all the tools for the individual, such as Jupyter Notebooks that we covered today and SPSS Modeler that we covered last time. Both are integrated into this platform. So however you like to build machine learning models, you can do so in one single platform that's built on a very enterprise scale that allows for collaboration, teamwork, model management, and deployment. So thank you very much for watching this demonstration. If you have any questions, as usual, feel free to reach out to me via email or on LinkedIn, and have a great day.